So let's talk about half-life calculations. Half-life calculations is the time required for a reactant's concentration to drop to half its original concentration. So if I have 100 sample size, let's just make it simple. Let's talk about grams. If the half-life was 5 minutes, let's say after 5 minutes, then if I started with a 100-gram sample, after 5 minutes I'd have 50 grams, and then 5 minutes later I'd have 25 grams, and then 12.5 grams, and so on. So half-life is whatever it takes, so you never have zero because you're always taking half of whatever you have away. So that's kind of what I was talking about here, and we can say that then for all first-order reactions, the half-life is ln of 2 over k, because that's always going to be 2, as we demonstrated with 10 divided by 5 a moment ago, right? When half the sample size, that ratio is going to be 2. So therefore, we can say the half-life of a first-order reaction is always going to be whatever this ln of 2 comes out to be, which is this, 0.693 over k. This is an example of what we could do, and this will come up in your homework, where we don't have to have concentrations. We can just have an x amount. Okay, so this x, instead of having an a, and there's no square brackets because I'm representing an amount instead of a concentration. Okay, so now we're going to get to example 11, and we're going to look and see some similar relationships that we did in 10. All right, it says plutonium-240 has a half-life of 6.58 times 10 to the third year. So we know this is our half-life. Important that we don't make this time. Yes, this is a unit of time, but this is explaining that a half-life, this is specifically a half-life, not just T. There is a difference between T right here and half-life. Okay, so half-life is different. That half-life is this column where you have to calculate. Any of these can be, we could put this here. Oops, that disappeared. Okay, that little image went behind. I don't want to do that. So this could be put here, and I could say T equals each of these depending on the order. So that could be put either place. So this is a half-life, so we know it's first order because it says calculate the first order. It doesn't tell us, but it says first order. If it didn't tell us, then we'd assume first order, but it does say that it's first order, so T half-life equals this. I'm getting that from looking here because this is the first order column, 0.693 over k. I know my half-life right here. I'm plugging it in, and then I can cross-multiply and solve for k. So I like to say put this over 1 and then cross-multiply. That tends to help my students when I say put this over 1 and cross-multiply. So I put my half-life over 1 and cross-multiply, and I get this. Solving for k means I divide both sides by 6.58 times 10 to the third years, and then I get 1.05 times 10 to the negative fourth inverse years, because remember this is coming over, so years will drop down as a unit underneath the 1.